Okay, so we're going to call this section 8.3, and it's on rectangles. So I think this section will be pretty basic to start, because I think we all know what a rectangle is. Now, what the high school version of rectangles focuses on is the diagonals, okay, and then relationships between the diagonals and a little bit of the sides. So let's review a couple things here real quick. One relationship that we'd like you to know, is that a rectangle is a parallelogram. So there's a little bit of a logic table that goes with this. So if a rectangle is a parallelogram, it has all of the properties of a parallelogram, which was an 8-2. And what are those properties? Those properties: opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary. So if you hopefully you picked up on all of that in the last section. And the last one, the diagonal part, which is the new part, I need you to remember, it's up on the front of the board too, but the diagonals bisect each other. Okay, that means they meet at the midpoint. Now, here's what the rectangle adds, which I think you know, all right? So the first thing that we all know is that all of the angles are right angles. Oops, sorry. All of the angles are right angles. That makes them sort of practical. We're going to go through a practical exercise in class with you to try to use that rule, all right, which I think we already know. So if it says it's a rectangle, all the corners are 90 degrees. The other thing, which is very important, Mr. Neisen would like you to leave class knowing this, is that diagonals are congruent, and that has some, I can't spell today, sorry, diagonals are congruent. This has practical uses, okay, and I'm going to show that to you in class a little bit more, okay? So that's a lot of rules, all right, but I need you to work through the examples and do them. So this section goes fairly quickly, I think. So let's see what we can do. We do need one thing that we're going to be able to do because of this right angle, though, is we're going to be able to use Pythagorean theorem. Can you see this triangle right here? Okay, so that's also maybe a high school version of that. So let's look at number one. Let's see if we can do it. Okay, so let's do the easy ones here first. What is QR? You see that QR is 10 because we know that opposite sides are congruent. What is SR? SR is 24 because we know opposite sides are congruent. Now, SQ is here. Okay, now this takes a little bit of work then. Okay, so what is that diagonal? Well, I can find that diagonal for this shape, not for a parallelogram necessarily, but for this one. Why? Because of this 90. Okay, in this case, do you see this triangle right here? So what can I do, hopefully from the last test, right? If you take 10 squared plus 24 squared, that's annoying. Thanks, Mr. Little. Jeez. Okay, so if you have 10 squared plus 24 squared equals x squared, right? Equals the hypotenuse squared. So again, I had people on the last test get that mixed up. Remember, the hypotenuse has to be by itself. Now, in this case, you get a little lucky because it's 2 legs squared equals that. Anyways, if we solve this quickly without wasting your time, I assume you can put that in your calculator and get 676 equals x squared. That tells me x equals 26. So that's 26. Now, here's the cool part. Okay, if we know this new rule right here, okay, if this is 26, here, let me highlight that, I guess. If this is 26, guess what? This is also 26. So that makes that pretty simple. Okay, and then the last one, what would QT be? Now, that requires us to use the rule here that they bisect each other. So if the whole length is 26, what is this? This is the midpoint. So another property is, if you can think about it, if they bisect each other, all these are exactly the same. Because if the whole length's the same and they bisect each other, each one of those little pieces are the same. Hopefully, relationally, geometrically, you can figure out that it's half of it, which is 13. Okay? So hopefully that strikes you as being, yeah, okay. So we'll see what happens here then. All right, so let's look at the next one here and see what we do. Let's go to number 3. Let's look at one with angles. So look at number 3. I give you that this is 27 degrees here. Now, the other thing that you know, remember, is that this whole thing is 90. Okay, so let's see if we can put some angles together. All right, so if that's 27, what is MJK? Okay, so MJK is this whole thing. That would be 90, right, for that one. How about MJL? So MJL is looking for this one. Okay, I'll try to make it so you can see it. What would that be? If we can use a geometric word, that's going to be the complement to 27. You buy that? Because this whole thing's 90, this is 27. What is this? This is going to be 63. And how did I get 63? I took 90 minus that. All right, how about JKL? Okay, so, all right, sorry, JLK. So how about this angle? Now, here's another thing. Now it's all coming together. What's true about a rectangle? It is a parallelogram. So this is parallel to this. Now, this goes back to, like, oh my gosh, when it was warmer outside and we just started the class. What's true about these two angles right here? Okay, I'm hoping you say something like, I don't know, well, don't forget this is parallel to here to here. It's probably more practical for this one. So what's true for those two angles? Those are alternate interior angles. Remember that term? So what's true? That's equal to that. So this is also 63. Can you see that? Okay. Now on the flip side then, what is KML in here? What would this be? Here, I'll try to make my markings, I guess. By the same token, either by parallel angles, or you can even break it into triangles. Remember, all these little triangles, the triangle sum theorem always works, so you can get there. But if we just translate from here to here, again, by the same token, this is also going to be 27, okay, related to this. All right, and the last one says, what is MNL? So what would this angle be? Okay, let's think about that for a second. Okay, what would this angle be? So if we look at that, right, if this is 27, this is a little bit complicated. Let me try to see if I can explain it to you. Okay, and if you can follow this, this shows good logic. So if this is congruent to this, okay, and this is 27, okay, what kind of triangle is that? That's an isosceles triangle. What do we know about isosceles triangle? That this angle is equal to this angle. So this angle is also 27. So then how might I find that angle in the middle? Well, what's true? Triangle sum theorem still works. If I take 180 minus 27 minus 27, I get 126. Okay? Whoa. So I do want to explore that, okay? So if you can work with me here, this section's pretty short, but I do want you to explore all that. There's a lot in there. Do you see it? There's the word bisect for there's the word diagonals are congruent. There's use of the diagonals bisect each other. There's triangle sum theorem. There's alternate interior angles. So if you can use this exercise and take an extra minute to explore all these and think about them, that's how I would like you to play it, okay? And work through all that. There's a lot of review there, okay? All right, now, let's look down here quick then. So the next one here, without going through it, they are going to have you mark them. So when you get a question like number 5, I want you to mark it and then diagram it. Just let me look down here quick. This is good for Algebra 2, by the way, that when we go through stuff like this, we're going to put some expressions in there that helps you put it together. So I think we've been through this a decent amount. If I look at number 6 without solving them, I think we get the idea, right? What's true about those two? I would take 3x plus 5 and set it equal to 7x minus 39, right? So if I do a couple setups here, I'm assuming that's good, right? So you could put those together and do it. And then let me see if there's anything else that you need to know. Over here, okay, this uses the rule of RT. They give you RT and US. This is the big takeaway that I'd like you to leave the class with, is that these two are congruent. So what would you do? You would set those two equal to each other and solve it. Okay, when it comes to angles, same thing. If you look down here, I don't know if we explained this to you or not, but what's true about this angle and this angle? All right, again, those would be congruent, and we could put it together. Let me find one where I might have to put it together a little differently. Let's look at number 13. Number 13, this one's a little trickier. It relates to what we did. So when you have this and the diagonals are congruent, so this is congruent to this, and if this is the midpoint, this is congruent to this is congruent to this. So what does that mean? That means this is congruent to that. Holy cow. And then it's asking for you to find this part. So let's review one other thing for supplementary angles. Can I find this angle right here? I think I can. So if you're following me there, how would I find the red angle? I would take 180 minus 134, right? And that would give me 46, I think, if I'm doing my math right. And then what could I do? The thought would be, I have a triangle here, okay? So what triangle sum theorem still works? So what would I have? I'd have 5x plus 7 plus 5x plus 7. All you guys are good at just writing 10x plus 14, that's fine. Plus 46 equals 180, okay? And then, right, because that's the three angles, this angle plus this angle plus this angle, triangle sum theorem, okay? So that's not all of it. We're going to do an exercise in class, and then we're going to go through some other examples. That should give you enough then to participate in class and maybe even start the assignment.